Happy morning, my dear children. Happy morning. Okay, today we have to learn about that coordination compound, the same lesson. Today our learning objectives to learn about the isomerism of coordination compound. Isomerism of coordination compound. In the small class, you maybe learn about the isomerism. What is about the isomerism? Compound having the same molecular formula but the different structure, am I right? Different structure are called as the isomerism. But here also same like that we are going to learn about that. In coordination compound having the same molecular formula but different the physical and chemical properties, and also here the different ligands. Ligands are arranged in the central metal atom. Different arrangement of ligand to the central metal atom. This is called what? Isomerism. About the isomerism, the isomerism can be classified into two types. One is the structural isomerism and another one is the stereoisomerism. Structural isomerism, stereoisomerism. The structural isomerism are classified into four types: linkage isomerism, coordination isomerism, ionization isomerism, and also hydrate isomerism. These are the four major classes. What are they? Linkage isomerism, coordination isomerism, ionization isomerism, and also solvent, otherwise called hydrate isomerism. Next up to the stereoisomerism means we are classified into two types. One is called as a geometrical isomerism. Then we are saying about the cis and trans isomerism. Cis and trans isomerism. Next one is called as an optical isomerism. Let us we can be discussed one by one. Here what are we are going to learn? Today our learning objective is to learn about the importance of definition of isomerism. Okay, each different classes of isomerism with an example. So anyhow today our learning objective to learn about the isomerism in coordination compounds. Okay, so today you should be learn about the definition and the example. We are expecting that only the definition. Each subheading you should be learn the definition and also the example. Please all of you take the note. We can be write the each types of isomerism with an example. Please all of you take the note. Isomerism in coordination compounds. Isomerism in coordination compound. What is about the isomerism? It is a phenomenon in which more than one coordination compound having the same molecular formula have different physical and chemical properties. Clear? Having the compound having same molecular formula are same, have different physical and chemical properties due to the different arrangement of ligands around the central metal atom. Okay? What is about the isomerism? It's an important question. Isomerism is the phenomenon in which more than one coordination compound having the same molecular formula have the different physical and the chemical properties due to why this happens means due to the different arrangement of ligands. Here the ligands arrangements are different around the central metal atoms. Here the isomerism are broadly classified into two types. Okay, isomerism are broadly classified into two types. First one is the structural isomerism. Structural isomerism. Second one is the stereoisomerism. Structural isomerism and stereoisomerism. Here, the structural isomerism can be classified into four types. Here can be classified into four types. One is the linkage isomerism. First one is the linkage isomerism. Second one is the Linkage. Next one is the ionization isomerism. Next one is the coordination isomerism. Coordination isomerism. The last one is the hydrate isomerism. Okay. The structural isomerism is classified into four categories. One is about the linkage isomerism. Another one is the ionization isomerism. Another third one is the coordination isomerism. The fourth one is the hydrate isomerism. And the stereoisomerism can be classified into two types. One is the geometrical isomerism. Next one is the optical isomerism. These are the isomerism of isomerism in coordination compound. About the structural isomerism. Here, what is about the structural isomerism means the coordination compound which have the same formula. The formula is same, but which is the different? But have the different connection among their constituent ion or atoms are called structural isomerism. Okay, the coordination isomerism, coordination compound which have the same formula is the same, but have the different connection among their constituent atoms are called structural isomerism. Okay, I told you that there are four different types of structural isomerism. One is called about the linkage isomerism. Which isomerism? Linkage. The first one is the linkage isomerism. Sometimes each isomerism can be asked in 3-mark or 2-mark question. You should be learn the definition and example is enough. Okay. There is no need to write the explanation. We are expecting only write the examples and also definition. Linkage. First one is the linkage isomerism. Linkage. Okay, first one linkage. Here the concept, what is the concept? Here, the ligand is bonded to the central metal atom. That's the concept. What is that one? The ligand having each coordination compound having ligand, am I right? What is about the ligand? The previous video we discussed about the ligand. Ligand is a group of atoms or ion attached to the central metal atom. For example, K4, Fe, is Cn and 6. Okay. Here, this is the counter ions. This is the central metal atom. This is the ligand. Am I right? Here, ligand is attached to the central metal atom. Here, about the linkage isomerism. What is about the linkage isomerism means? The ligand is bonded to the central metal atom or ion through either in two different donor atoms. Here we are taking an example is ambidentate ligand. Okay, which ligand? Ambidentate. And very good example is nitrite, NO2 minus nitrite. Nitrite means here nitrogen can be bond to central metal atom, or oxygen can be also bond to central metal atom. Here one nitrogen and also two oxygen is there. The nitrogen atom can bond with to the central metal. That is we can be taken as an example is. But an example is cobalt, Cu, cobalt, NH3, that is ammonia, 3 times, NO2 thrice. This is one of the complex, one of the coordination complex. Okay. Here, this is an ambidentate ligand. This is a neutral ligand. Ammonia is a neutral ligand. Already I told you about that. Ammonia can be write as an amine. How much ammonia is there? 3 amine. So we are saying triamine, trinitro, cobalt 3, ion. That is the name of the complex. Am I right? It's the name of the complex. Here, this is an ambient Indian ligand, NO2, because it can be attached by means of nitrogen and also oxygen. And nitrogen and also can be attached. Okay. Anyhow, nitrogen attached means it becomes in one color, and oxygen attached means it becomes another color. The color is different. Okay. Linkage by means of linkage. Am I right? So here linked with the central metal atoms and also the nitrogen element. Okay. Linkage. There's a bond between. What's about the bond to the central metal atom or ion? Throw either two different donor atoms. Throw either of its two different donor atoms. This nitrogen is also donor atom. Oxygen is also donor atom. If we are attached by nitrogen means it is called as a nitrogen attached. Nitrogen attached to the central metal, that is cobalt. Nitrogen is attached to the cobalt. Suppose oxygen attached means O attached. Okay, that is oxygen is attached to cobalt. Okay, so what is the definition? You should be write the definition. What is the definition means? This type of an isomers, that means linkage isomers, arise when an ambient ligand is bonded to the central metal atom or ion through either of its two donor atom. This is the definition. What's the example? This is the example. Then you should be draw the structure. What is the structure? Means here central metal atom is cobalt. Am I right? Which one is the central metal atom? Cobalt. Cobalt is the central metal atom. Okay. How much ammonia is there? So we can be written as 5 ammonia. Okay. Taken like that. Another example. 5 ammonia. As per the textbook, we are taking the 5 ammonia. So what's the name of this compound? Pentamine. Because the 5 ammonia group is there, neutral compounds. Okay, pentamine, nitrito, cobalt 3 ion. Okay, so 5 ammonia is there. So you are surrounded by 5 ammonia. There is here 1 ammonia, NH3. Second ammonia, NH3. Third ammonia, NH3. Fourth ammonia, NH3. Fifth ammonia, NH3. There is 5 ammonia is over. Next one, nitrite. Here taking nitrogen, oxygen, one of the arrow mark oxygen, okay? Because it is a coordinate covalent bond, okay? Arrow mark, we should be clear. And also, the entire complex is what? 2 plus. Here, I told you that nitrogen is attached to cobalt. So, N attached. Okay? N attached. That is, nitrate ion bonded to the central metal atom cobalt through a nitrogen atom. Otherwise, we can write one more example by oxygen atom. That is, cobalt, NH3, 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 NH3. Here I wrote nitrogen. Here I am saying oxygen. Okay. Next, nitrogen, oxygen. The total NDR complex is plus 2. 2 plus. Can you understand? Can you differentiate the two structure? As per this example, the textbook example, cobalt, okay, with 5 ammonia and 1 nitrite ion, okay. Anyhow, here the cobalt is attached by nitrogen. Nitrogen is attached by cobalt. Here also oxygen is attached by cobalt. Okay. So anyhow, in this example, we can learn that nitrate ion is bonded to the central metal atom. Nitrate ion is bonded to the central metal atom. Okay, that is cobalt. Through by a nitrogen atom in one complex and also oxygen atom in other complex. That's the example. So, what is the example? What is the definition? Linkage isomerism. When an ambient ligand is bonded to the central metal atom or ion through either of its different donor atoms, different donor atoms. Example what? Example. The nitrate ion, we are taking the nitrite ion, NO2 minus, okay? Nitrite ion is bound to the central metal atom of cobalt through either by nitrogen or oxygen. This is an example. Next about the coordination isomerism. What is about the coordination isomerism means there is an interchange between one or more ligand between the anionic and cationic complex. We are taking two complex. Example, for an example, I am taking one example. CO, cobalt, NH3, 6. Here I am taking chromium, CN, 6. This is one of the coordination compound, am I right? Can we say the name? What's the name? First priority goes to amine, second goes to cobalt, next to cyano, next goes to chromium. How can you say the name? How much ammonia is there? 6 ammonia can be written as hexamine, cobalt 3, hexacyano, chromate 3. Okay, because this is a positive, this is a positive, this is the negative. Am I right? Cationic complex, anionic complex. Anionic complex ends with the 8. Okay? Hexamine, cobalt 3. Next one, hexacyano. Here you should be right, not chromium, chromate 3. This is the name of the complex. Here what is happening? There is an interchange of one or more ligand atom between the anionic and cationic complex. That means here the interchange of ligand, this cyano group will be attached, it will occupy here, and the ammonia group will be occupied there. We are interchanging. It will be attached to this complex. Here NH3 is attached to second complex. Okay. So what is the next complex means CO. Can you say what is the next one? Cyano group will attach here. CN6. Then Cr will be attached there. NH3. So what is the name? Can you say what is the name? How can you write the name? Otherwise the easiest way you can write as for easiest way. Easiest way means first we write with chromium here. Cr NH3 is 6. CO CN is 6. Give the number 1, 2, 3, 4. Can you say what is the name of the complex? What's the name of the complex? Hexamine, amine, that is amine 6 having hexamine, chromium 3, hexacyano, cobaltate 3. Okay, hexamine, chromium 3. Okay, hexamine, chromium 3, oxidation state is 3. Previous video I explained that. Next about the hexacyano, cobaltate 3. This is the name of the complex. Okay. So anyhow, you should be give the definition. What is the definition means? The coordination, this type of an isomerism arises, the coordination isomerism. This type of an isomerism arises in the coordination compound having both the cation and the anion complex. This is on the cation complex, this is on the anion complex. This is one of the cation complex, this is one of an anion complex. Clear? Here having both complex. Here what is happening means there is an interchange of this ligand interchange of this ligand, the interchange of one or more ligand between the cationic and the anionic complex. Okay, between the cationic and anionic coordination entities to form a different isomer called coordination isomer. That is, there is some changes due to the ligand in the coordination. So we are saying that on coordination isomer. Okay. Next about that, ionization isomers. Ionization isomerism. What is about the ionization isomerism? There is an exchange of ions in the coordination entities. Okay. What is about ionization isomerism? Exchange of ions in the coordination entities. That is called what? Ionization isomerism. We can be simply say there is an exchange of ions in the isomerism is called, in the coordination isomerism is called coordination isomerism. Okay. For example, what is the example means? We are taking platinum, ethylene diamine, Cl2, enter the complex, Br2. Can you take the other one? Here, the chloride ion is replaced by Br2. Here, Br2 is present in the coordination entity, but chlorine is leaving out. Okay, so what's the next one? That is PT, platinum, ethylene diamine, Br2, Cl. Okay, so we can give, what is the definition we can give as per the ionization isomerism? This type of an isomerism arises when an ionizable counter ion, that means simple ions. Okay, this is a simple ion. The ionization counter ions itself can act as a ligand. It itself acts as a ligand. Here, what is the definition means? The exchange of counter ion, this is the counter ion, exchange of counter ion with one or more ligand in the coordination entity will give the ionization isomerism. That means here the exchange of this counter ion through the coordination entity, by the coordination entity give rise an isomer called ionization isomerism. Okay, this is about the first compound. Okay, here bromine is the counter ion, am I right? Bromine is the counter ion, otherwise called simple ion. The second isomerism, the bromine will be attached on the inside the coordination entity and the chlorine will be leaving out. Okay, so this is the second isomerism. There is a small changes by means of an ions that we are saying ionization isomerism. Okay, the next one is a solvate isomer, solvate isomers. Okay. That means otherwise we can say about that hydrate isomers. Hydrate. What is in the hydrate? Hydrate means water molecules. Okay. Solvate. Hydrate isomers. First of all, I am saying about the example. Okay. Here we are taking chromium. Chromium. Here water molecules come in six water molecules. Okay. Cl3. You can take Cl3. Second one, here having 6 molecules of water. The second one, 5 times. One of the chlorine will be enter inside. That is Cl3 having. One of the chlorine will be enter inside, and one of the water molecule will be leaving outside. Okay. So we get Cl and also Cl2. Okay, am I right? Cl2. In between Cl2, after that you should be right. One of the water molecules leaving out. Am I right? That also should be right. Okay. Next again the third one. The third one also like that. Cr(H2O). Again we are taking one more water molecule to outside. Chlorine also will be attached inside. Okay. Cl2H2O. Anyhow, when we are counting it in must have 6. Here 6 water molecule. 4 plus 1 6. 4 plus 2 6. Total inside must be 6. Okay. Anyhow, these are the examples of solvent isomers. First one having 6 hydrate molecule, water molecule. Second complex having 5 water molecules. Next one having 4 water molecules. Here, you should be say the color of the complex. What is the color of the complex? First 6 water molecules that we are saying about the violet color and gives 3 chlorine ions. Okay, what's the color? Violet. Violet color with 3 chlorine ions. Okay. Second one, 5 water molecules, pale green color. Okay, pale green color. Here having about 2 chloride ions. Here 4 means dark green color, dark green. Here having only 1 chloride ion, only 1 chloride ion. Okay, here, these are the 3 examples. For the one word, ask about the one word, for the next students will ask the one word about. Here, what is the color of this complex? What is the color? Violet. Okay, what is the color of this complex? Pale green. What is the color of this complex? Dark green. Can we say, how can we say the name of this complex? Okay, can we say? First give the priority to ligand. Second to central metal atom, next to chloride. Okay. Consider the name of the complex. Here having how much water is there? 6 water. Water you should be say as aqua. So how much aqua is there? 6 aqua. So what's the name? Hexa aqua, chromium 3 chloride. What's the name of the compound? Hexa aqua, chromium 3 chloride. Can you say this name of this complex? First gives to ligand 1, second this ligand, third central metal atom, fourth, fifth. Can you say the name of the complex? How much water molecule is there? 5 water molecules. 5 water molecules means penta aqua, chloro, chromium 3, chloride, monohydrate. What's the name? Pentaqua, chloro, chromium 3, chloride, monohydrate. Okay? Can you say the name of the complex, the last one? First one, second one, third one, fourth one, fifth one. Can you say the name of the complex? 4 water molecules, so you should be saying 4 water molecules. Here we have 4. So, tetraqua, dichloro, chromium 3, chloride, dihydrate. Did you have any confusion about this example? Inside the coordination sphere, water means we should be say aqua. Outside the coordination sphere, you should be say hydrate. Okay? Inside means aqua. Outside means hydrate. Outside 1 molecule means monohydrate. 2 molecules means dihydrate. 3 molecules means trihydrate. Okay. Can you say, once again, can you say the name? What's the first one? How much water molecule is there? 6. So, hexaqua, chromium 3, chloride. Okay. We learned that today, that means the day before day, we learned the IUPAC rule. Okay. Those who have watched that video, we can be say the name. What's the name? Tell me. Hexaqua, chromium 3, chloride. Second one, pentaqua, chloro, chromium 3, chloride, monohydrate. Next one, tetraqua, dichloro. Here I have 2 chlorine. Dichloro, chromium 3, chloride, dihydrate. Okay. These are the examples. About the definition. What is about the definition? How can we say the definition? The exchange of free solvent molecule. The exchange of free solvent. Solvent means water molecule. Exchange of, here the water molecules are exchanged because the first one is having 6 water molecules. Second one are having only 5. Third one is having only 4. Okay, so anyhow, the exchange of water molecules, clear? The exchange of solvent molecules, otherwise water molecules, in the crystal lattice with a ligand in the coordination entity will give different isomer. Will give different isomer. This type of an isomer is called solvate isomer. Which isomer? Solvate isomer. Then these isomer are called hydrate isomer. Which isomer? Hydrate isomer. Okay. Here having 3 hydrate isomer. This is one hydrate isomer. Second hydrate isomer. Third hydrate isomer. The first one is the color of the isomer is violet. Second one is the color of the isomer is pale green. The third one is the color of the isomer is dark green. Okay, dark green. So okay. Anyhow, the violet is having no chloride ions here. Violet is having 3 chloride ions. And about the pale green have 2 chloride ions. And about the dark green having only 1 chloride ion. Okay. For the one word, they will ask about the one word. Okay, make it. Next to learn this example. Okay, anyhow. Next about the stereoisomers. What is about the stereoisomers? Stereoisomers. What is about the stereoisomer? Here, the coordination compound has same chemical formula and the connectivity between the central metal atom and the ligands. But what is the difference means? The differ in the spatial arrangement of ligands in 3-dimensional space. Okay, in 3-dimensional space. Here we are classified into 2 types. One is the geometrical isomerism and another one is the optical isomerism. About the geometrical isomerism, what is about the geometrical isomerism means? Here simply we can be saying that different possible arrangement of ligands around the central metal atoms are different. That means similar groups are lying on the same side. For example, I am saying about the example. This is the metal. Imagine this is the metal. The metal atom is surrounded by the ligand. Am I right? We can be say this is we can be say DB. Okay, like that. Okay. Here, metal, here A, here A, B, D. Okay, like that. 2 examples. The similar group lie on the same side. The similar group lie on the same side means we are saying cis isomer. Which isomer? Cis isomer. The similar group lie on the opposite side. Opposite side. We are saying trans isomer. This is our condition. Okay. Similar group lie on the same side. That is AA lie on the same side. This we are saying cis isomer. Similar group lie on the same side is called cis isomer. The similar group lie on the opposite side is called as a trans isomer. Okay, that's a very good example for we can be write on an example. Then only you can be easily understand that. No? Similar group, for example, platinum, NH3 twice Cl2. The whole MDA complex is 2 plus. This is one of an example. Okay. Here platinum is the central metal atom. Okay. Platinum. Central metal atom. Platinum. How much ammonia group is there? 2 ammonia. Okay. 2 ammonia. NH3. NH3. Okay. Cl. As per this order, the similar group lie on the same side. So we are saying cis isomer. The similar group lie on the same side. We are saying what? Cis isomer. Okay. Okay, you should write the entire complex charge. What is the entire complex charge? 2 plus. Next one, we are taking the next one is PT NH3 Cl NH3. Entire charge is 2 plus. Okay, here the similar group lie on the opposite direction. Okay, opposite. So we are saying what? Trans isomer. Here. So we are writing trans isomer. Okay. Similar group lie on the same side. It is called as a trans isomer. Similar group lie on the opposite side is called. Similar group lie on the same side is called a cis isomer. Similar group lie on the opposite side is called what? Trans isomer. This is the examples of A2B2. This is the example. Sometimes draw the structure of Ma2B2. Draw the structure of Ma2B2 means I draw this structure. Okay, and also you should be mentioned the similar group lie on the same side is called a cis isomer. The similar group lie on the opposite direction is called trans isomer. That also should be explained. Okay, anyhow, next one example. Draw the structure of Ma2BC. Draw the structure of Ma2BC. Draw the structure of Ma2BC. Okay, here M means central metal ion. A2 means we are taking 2 ligand. This is also 2 ligand. Okay. Example PT NH3 twice Cl Br. This ions we are taking. Okay, and their complex is 2 plus. This is an example. Okay. Okay. PT NH2 one side we are saying chlorine, another one side Br. The total entire complex is 2 plus. Okay, the similar group lie on the same side. Similar group lie on the same side means what is that? Cis isomer. About next one. PT NH3 Br Cl. Entire complex is 2 plus. Here the similar group lie on the opposite direction, opposite side. We are saying the trans isomer here. This is an example for Ma2BC. Don't forget that Ma2BC. The before we draw the structure Ma2B2. Okay. So the question may be asked like that. Draw the structure of Ma2B2 and draw the structure of Ma2BC. Okay. And next also have the two more structure. You should be. If you are those who are interested, you can draw that one. Otherwise, we can learn the next one about the octahedral complex. Okay, octahedral complex. Octahedral complex. Here we are taking the example is Ma2B4. This is one of the complex. N plus or minus. Okay, Ma2B4. One is an example. We are taking one of the example. Here, what is about the M means central metal atom? What is meant by A? Here, A and B are monodendron ligand. One more example is also we can take metal X twice B2 N plus or minus. This is another one. Okay. Anyhow, here we are taking M is the metal, A and B are the monodendron ligand. X means bidendron ligand. Which ligand? Bidendron ligand. Anyhow, this one also you should be drawn. What is the structure? The position of the ligand. Okay, we should be learning the position of the ligand. What is the position? Okay. Okay. This is the first position. First position. This is the second position. Third position. Fourth position. Fifth position. Sixth position. Here, which are the trans and which are the cis isomer? That's the question. First, you should be learn the trans isomer. Okay, not cis isomer. Almost everything are the cis isomer. Expect 3 items. One is position 1 and 6. Position 1 and 6. Okay, 1 and 6. 1 and 6 are the trans. Then because it's opposite. 2 and 4. 2 and 4. 2 and 4. This is also an opposite. Next about the 3 and 5. 3 and 5. 3 and 5 also trans isomer. For this octagonal, don't forget that 1 and 6, which are the opposite, 1 and 6, 2 and 4, 3 and 5. Can you see which are the trans isomer? 1 and 6, 2 and 4, 3 and 5 are the trans isomer. Which isomer? Trans. Okay. Next, what are the cis isomer? What are the cis isomer means? The position we can be taken as 1 and 2, 1 and 3, 1 and 4, 1 and 5. Can you say 1 and 2? Okay, 1 and 2, 1 and 2, 1 and 3, 1 and 4, 1 and 5. These are what? Cis isomer. 1, 2, okay, 1, 3, 1, 4, 1, 5. These are the what? Cis isomer. These are the trans isomer. These are the cis isomer. And about this is the 2. Okay, 2, 2 and 3, 2 and 3, 2 and 5. This is 2 and 3, 2 and 5. 2 and 4 is a trans. Okay, that is no. 2 and 4 we know. That's a what? Trans isomer. Okay, 2 and 4. Here, 2 and 3, 2 and 5. 2 and 6 also trans isomer. Cis isomer. 2 and 3, 2 and 5, 2 and 6. These are what? Cis isomer. Okay, anyhow, which are the trans isomer? 1 and 6, 2 and 6, 3 and 5 are the trans isomer. What about the cis isomer? 1 and 2, 1 and 3, 1 and 4, 1 and 5 are the cis isomer. 2 and 3, 2 and 5, 2 and 6 are the cis isomer. And 3 and 4, 3 and 4, 3 and 6 also cis isomer. And one more having 4 and 5, 4 and 6 also. 4 and 6 is a trans isomer, okay? 4 and 5. Next one is 5 and 6. 5 and 6 also cis isomer. These are all the cis isomer, okay? Anyhow, don't forget that 1 and 6, or 2 and 6, 3 and 5 are the trans isomer. Remaining all are cis isomer. Okay? Anyhow, our today assignment, what is about the assignment means, I am giving only the definition and the example is enough. Okay? Only the definition and the example is enough. That is, 1. Linkage isomerism. Second on coordination. Third on ionization. Fourth on solvate. These are the isomerism, linkage isomerism, coordination isomerism, ionization isomerism, solvate isomerism. We are expecting only the definition and the example. Okay, definition and the example is enough. Okay, definition and the exam. Okay, thank you all of you. Thank you. Have a nice day.